So thank you all for joining our Lunch and Learn today on frost control. I'm Erica Pate, a fruit specialist with the Ontario Ministry of Agriculture, and I work on berry crops. So before we get started, I just want to ask everyone to mute yourselves for the presentation, but feel free to enter questions into the chat as we go, or you can unmute yourself afterwards and ask questions after the presentation. I am recording this. I think you should have gotten that notification, and then we'll share out that link afterwards. Okay, so that's mostly my housekeeping. So now to introduce our speaker, we have Kathy Demchak joining us today. She is a senior extension associate working on berry crops from Penn State University. And she's been with the university since 1983 and has worked with berry crops since 1992. And because of location and topography at Penn State's research farm near campus, she's had plenty of opportunities to gain experience with frost protection. And so today, Kathy is going to go over frost protection methods for strawberry growers for us. So I really appreciate her taking the time to join us today as our season is quickly approaching here in Ontario, and she's in the midst of, her season's a little bit further ahead of us and dealing with some potential frost. So thanks so much, Kathy, and I'll pass it over to you.
Yeah, thank you, Erica. Well, thank you everybody for joining us. I'm just going to launch right into my presentation. So I'm going to share my screen here, and participants can now see our screen. We're good. And get us into, okay, so there's quite a lot here to cover. And so I'll just kind of keep moving through things here. So, all right, so strawberry frost protection. And of course, the fun thing that is happening is that my slides are not advancing. I love it when this happens. There we go. All right. So, so there might be a little bit of a lag there when I advance, I guess. But anyway, so the last couple of years, like 2 out of the last 3 years, we've had some relatively warm winters. Fortunately, that hasn't been the case this year, much to a lot of folks' relief. But what's happened when we've had a warm winter, like we've had in the past, or sometimes we have fluctuating temperatures, is that the plants would come out of dormancy earlier than we'd like to see them do that. And so, of course, flower buds would emerge. And then it always seemed like that's when the temperatures would decide to cool down. And then we would end up with this frost protection season that would start early. The plants would just stay in, bloom or advance through it slowly. And so it would end up with a really long frost protection season, which was always pretty tiring. And so, so there were some different things we would see. One is, as you can see in this picture on the left, we'll talk a little bit more about why the damage that we had from frost, all those blackened centers on the flowers, why that was so extreme in this particular case. But when you have frost over a long period, if you aren't protecting over that entire period, then you're going to end up losing some blossoms, and you do run the risk of having damaged blossoms of different ages. One of the other things that we were seeing sometimes when it would get cold as the leaves were emerging was some cracking on the leaf undersides. And there's a group of us that gets together on Tuesday mornings to talk about berry issues. And that was a topic of conversation, what causes that. The other thing, and so that kind of cracking on the leaf undersides does seem to be from cold temperatures as that young tissue is expanding. The other thing that would happen sometimes, though, is, you wouldn't even get to bloom. You would just have blossoms open, and they would be black already. And that probably was from a combination of factors, and we'll talk about some of those too. The other thing we'd even seen, though, was our growth was advanced even on crops like raspberries, where we were seeing frost damage on, this is a red raspberry plant, which normally wouldn't be blooming until early June here, and that would be way past when we'd normally expect frosts, but we were getting damage to those plants. So there's different types of frosts and freezes we can have, and you may be familiar with this already, but we'll just review. Our typical frosts that we think about having generally, as we're in full bloom, might be a radiational frost, or at least this is traditionally the types of frosts we were seeing the most. And those would be the frosts whenever you had calm winds and a clear sky. And they're called a radiational frost because what's happening is there is, with no cloud cover, there's nothing to stop heat from radiating out into space. And so then your temperatures will drop. They will typically be cold at ground level. You might have an inversion layer above the lower layers, closer to the ground where you might have some heat. But by and large, what's happening is heat is escaping. And this type of frost, because it is calm, the conditions are calm, is relatively easy to protect against. But what we have that's going to be happening tonight here in Pennsylvania is something called an advective freeze. And under the conditions when this occurs, it's typically quite windy out. And the reason it's windy is because you're having a different air mass moving in, and usually it's a cold one. And so this really causes problems because, it's hard to use overhead irrigation. It's hard to protect against. And what you see in the picture on the lower right is blueberry blossoms that were damaged during one of these events. And you can tell which direction the wind was coming from. In this particular one, it was the northwest. And so those flowers were getting damaged. This has happened, of course, quite often. But when it really becomes a problem is when the plant growth is advanced in the spring. And so you have your plants in bloom or approaching bloom when this is happening. It's not such a big deal if it's happening when the plants are still dormant or, perhaps under straw mulch, of course, wouldn't really be an issue. This is April 2023 where there was some damage to tree fruit in the northeastern U.S. and then also in Canada, in Ontario, and Quebec. And what this map is just showing that what was happening in April 2023 was that we were getting a lot of wind out of the north. And so this particular map where it's orange is showing what was happening relative to the 1991 to 2020 period averages. And so the darker red means that we were a little further out of whack from usual, I guess. And what happened in that particular month was that our north to south wind, which is this V component that is in the title for the graph, that's the north to south wind, that was averaging quite a bit faster than usual for the entire month, probably because we had a couple of events move through where we were getting that northern wind moving in. So what's our critical temperatures for strawberries? So the critical temperature where you're going to have damage is going to vary depending on the growth stage. And so you can see that here in this slide, we have different temperatures given both, Celsius and Fahrenheit, because I'm used to Fahrenheit and it keeps me grounded and from saying some things. Anyway, so what we have is in Celsius as you go through from flower buds emerging, where you can, you need to get down to some fairly low temperatures before you are going to see damage. And then as you move through tight bud, popcorn, and open blossom, you can see that the flowers become, and the floral parts become more sensitive as the crop advances. And then what happens is when you get to green fruit is actually a little hardier again than the open blossoms. So, so you don't need to frost protect necessarily early on. I know everybody does get concerned about that. And there are reasons for that. Even though these are our critical temperatures, you do have some radiational cooling off of the plant. So the plant can actually be colder than the air temperature. And that's one situation where I think we see some damage. I think also sometimes we get to very cold temperatures when the buds are still down in the crown, just starting to come out, and we don't realize maybe, or pay attention to how cold it might have gotten when we're at that stage, and sometimes get to some pretty cold situations. So anyway, so these are the critical temperatures, but they really only hold if your measurements you're taking in your field are also reliable. So it's important to know the temperatures can vary a lot. Whenever you get a weather forecast or you see a weather report, the readings that you are seeing are typically taken at a 4 to 6 foot height. And so what you see in this picture on the upper right is a weather station. The sensor is actually inside of that little stack of white plates that you see there, which are there to protect the sensor from the sun so you don't get high, readings that are higher than what they actually are, and also to get airflow through and around that sensor. So, so that's not going to be the same temperature as what you're going to see at ground level in your strawberry field. It's going to be colder out there. Sometimes folks will tell me, well, at the house it says such and such temperature, and chances are it's going to be colder out in the field than on the porch too. And so what's important to do is to compare the temperature in the field to the temperature where you normally take your reading, and adjust if you need to. So there's some different factors that matter in what temperatures we see. One is, obviously the air temperature that may be referred to as a dry bulb temperature. Dew point and relative humidity, wind speed, sky cover, these all affect whether we have a frost event and what you can do about it. And so we will talk about that more in a minute. And then we'll also talk a bit about wet bulb temperature. This is a useful measurement, but often you don't see it reported in very many places. So just one thing to talk about related to thermometers. So these are good old-fashioned thermometers, which, don't normally cause us too many problems. But so anyway, so the liquid and glass type that you see here in this Minmax, where you have, a glass tube and something, a liquid inside of that tube that expands or contracts, those actually work pretty well for the cost. So they're economical. They can be off though. If you ever go to, I don't know, even a store and you look at their thermometers, if you flip through the different ones that are on the shelf, you're going to see that they vary in readings. So they can be off. One thing you want to do is check the accuracy of them. And so if you put together a crushed ice and water slurry and stir it, that is going to be at 32 degrees, 0 degrees Celsius. And and then if you stir it and you keep that temperature within that slurry pretty constant, you'll be able to calibrate your thermometer. So what you want to do is put it into that slurry wherever the bulb is. And so one thing that's important to point out is in a min-max thermometer, like you're seeing here on the right, the bulb is actually at the top of the thermometer. And so you either need to put it in upside down, or you can lay it down in that slurry to see whether it's accurate or not. And then just write, is it reading 1 degree low or 1 degree high? And if you can write on there what you need to do to adjust overnight if you have one of these out in your field, like subtract 1 degree from the reading, that's helpful. It helps to write something on there if you're in the middle of the night and you're sleep deprived, to write something that's pretty clear about what you need to do. So dial thermometers work too, but they're usually less accurate. The other thing, if you have somebody new on your farm or somebody who isn't familiar with min-max thermometers, it's really worth it to point out to them that the scales on the minimum and maximum side of the thermometer go in opposite directions. And so you just need to make sure that you're getting the correct reading when you're on the minimum side, because everything's backwards. And sometimes that throws some folks off. So one of the things you may see whenever you're buying a thermometer is its accuracy. And you may see that it also has, if it's a digital one, that it might have a lot of digits on it. And what's important to know is that it needs to be accurate. You don't really, you may get the impression that something is more accurate than it is just because it gives you a lot of digits. And so typically there will be something on the package that will give you the degree of accuracy it has. This might be given in degrees, or it could be given in a statement, something like that it's accurate to within 0.5% of its range. And what that means is if you multiply that entire range that it can measure, so say minus 51 Celsius to 60 degrees Celsius, it would be 0.5% of that range, which would work out to about a half a degree Celsius. That always threw me early on as to what they really meant. You can also use thermocouples and thermistors. What you see in the picture on the right is actually a thermocouple that is in a device that's used, a pocket device for measuring various variables. And they're typically pretty accurate after a few years, though. Generally with the literature you get with them, it'll tell you when you might need to recalibrate. Usually thermocouples and thermistors are attached to some sort of an electronic device. And we already mentioned, seeing a lot of digits. So, if something's measuring to the 100th of a degree, it may be off by a couple of degrees, just telling you that very with a lot of resolution. The other thing I want to point out is electronic displays aren't always made to withstand below freezing temperatures. So relative humidity and dew point. So temperatures drop fast when the air is dry. And so that's just one important thing to know. Dew point is a temperature where you have dew form, as you could guess. So that's when water's condensing out of the atmosphere. That tends to be, it is lower when the air is dry. When that condensation starts happening, though, that water that's condensing is giving off heat. So often the temperature stops dropping then, and sometimes that ends up being the low temperature for the night. One of the things that's important to point out is if the dew point is actually below freezing, as it is, for example, tonight here, where it's going to be like 12 degrees, temperatures drop really fast, and you won't ever see a white frost forming on any of the surfaces, and sometimes that's referred to as a black frost. Just because you don't see that white frost, that doesn't mean that the temperatures are not below freezing yet. And that's what happened in this case, where a grower was waiting to turn on the irrigation until he saw frost form, and instead he basically lost all of his blossoms. Dew point can be calculated from relative humidity and temperature, but it's a more complicated calculation than I want to explain right here, but it can be done. So wind. So a light breeze can mix the air. So that'll mix, top to bottom layers of the air and keep it stirred up. And so then you end up with temperature that's more uniform, both distance-wise and then also elevation-wise. So that can be helpful to have a light breeze. Problem is, if you get more than a light breeze, it's going to be difficult to frost protect. Obviously, it disturbs the sprinkler pattern, but also you're going to have cooling happening from evaporation, just like you do during the summertime and on a hot day when you're sweating and it gets breezy and you feel better. Sky cover also affects whether you have a frost occur. So when cloud cover moves in, you may notice that the temperatures stop falling, or they may actually go up a couple of degrees. So wet bulb temperature is something folks ask about sometimes. Traditionally, a wet bulb thermometer was one that would have a bulb covered with a wet fabric, and then sometimes referred to as a psychrometer, and you'd whirl it around. And what it would tell you is if once the water evaporated, what your temperature was actually going to be. And what this translates into in terms of practicality is this is also what your plant's temperature is going to be when you turn the irrigation on and you have evaporation taking place. So where it has some use, or one of several places where it has some use, is that the irrigation should be operating by the time the wet bulb temperature equals your critical temperature. And so that's where, where probably the greatest utility actually comes in. If you are using a wet bulb thermometer that has a wick, once you reach freezing, so if the temperatures are lower than that, the water's freezing and giving off heat, and so your reading might actually be a bit too high. You'll see a bigger difference between wet bulb and dry bulb temperature when the air is dry. So it can be calculated. There's an online tool that you can use to calculate this from temperature and relative to humidity. And it's pretty easy, it's a very easy online calculator to use. If you just Google, calculate wet bulb from temperature and humidity, that'll pull that up probably pretty quickly. The other thing you can do, though, is you can calculate it yourself. And so the wet bulb temperature is pretty darn close to the air temperature minus 1/3 of the difference between the air temperature and dew point. So you'll often see those two things reported, by various weather forecasting units, air temperature and dew point. And so if you subtract those from each other, take 1/3 of that and then subtract it from the air temperature, you will have a good idea of what your wet bulb temperature is. I've calculated that over a number of different combinations of temperature and relative humidity. And you might be off by maybe 1/4 of a degree centigrade, but really not typically any more than that. Okay, so what are some frost protection methods? Well, the first thing is to avoid having a frost in the first, your plant's exposed to a frost in the first place. And so if you're where you have some large bodies of water, excuse me, so I'm envious of you all right now, that can help a lot with avoiding frosts. Topography and air drainage is another big factor. So you don't want to be where our research farm is located. And so what you are seeing here, right here in the picture, is we have some hills around us. And where our research plots are actually located are primarily down on the valley floor. What you see there is an area that is uphill from the valley floor right behind that line of trees that is in the just behind the plots that you see here. In this picture, there's corn there. Right now, that was just a temporary crop. There was tree fruit up there. Now there are wine grapes up there. And so just getting those crops that are susceptible to frost up off the valley floor helps a lot. And the same thing would happen with strawberries if we were up there. Our problem is that we do not have irrigation up there. And so we're pretty much limited to the valley floor. And that's where all the cold air sinks. Other things that can help, some soil moisture. If the ground is wet, it'll hold a little more heat. And you don't want to, necessarily wet it and cool it down with the day that a frost is expected. But if you do it a little bit ahead of time so you can have some heat build up, that can help. Heavier soils will tend to hold more heat as well. You can't really affect your soil texture and compaction, nor do you want to compact to hold more heat. But if you have a sandier soil, you're not going to hold as much heat. So it's just something to be aware of. And then ground cover like weeds or anything else growing on the surface will also tend to hold some of the heat in to the soil, so it's not released to protect your crops right there in the canopy so much. So other avoidance approaches. So sometimes growers will leave straw on to slow the spring growth, and that is fine. You just don't want to go to extremes on it. So typically what we will say with straw mulch is to remove it when the soil temperature is right around 40 degrees. Well, 40 degrees Fahrenheit, 4 degrees centigrade. And what that'll do is, well, that's about the temperature when plants will start growing. And you don't want to be leaving that straw on when the plants are really trying to grow and put out growth, because then they're using all of their carbohydrates to try to grow that new tissue without getting any sunlight and being able to make, additional energy to help support that growth. Row covers, if you're trying to avoid frosts, we'll typically recommend actually taking them off as early as possible in the spring, again, right around that 40-degree soil temperature, so that the plants aren't getting advanced too much underneath that row cover. If you want to advance the crop, that's fine, but you can manage it in different ways to kind of spread out your harvest season. And then typically then we'd only pull them back on for frost protection. So you can do all these things, and try to avoid frost as much as you can, but you're still going to need to do something some nights. So there are different ways of doing this. Used to be that maybe you'd, burn something out in the field, and that's not really used anymore. Wind machines are something that are a question mark. So they work by mixing warm air. And typically this will be up, maybe 20, 30 feet above the crop, with cold air near the ground. And so that's why a lot of the permanent wind machines you'll see are quite tall, as they're trying to make sure they're going to get that warm air down to ground temperature or down to ground level. Um, and because they're expensive, typically they're, used in orchards where you have a more permanent crop, rather than compared to, for example, strawberries. So there is a portable version that is out there now, and it probably does. I'm sure they do have some utility in some situations. It may just, it's going to depend on the event. What I do understand from a little bit of research that I've found is that because they are lower, they aren't able to access as much of the warm air as, a permanent wind machine. And so you'll tend to get less of a benefit from them. So if you're in a situation where, you don't have another frost protection method, and you expect that you have some warm air above to mix in, and you don't need a whole lot of frost protection, they can have some benefit, but it's, only going to be a portion of the frost events you might have. One other thing is that if you don't have an inversion layer and you're just blowing air around, I did run across a couple reports of possibly some damage from evaporative cooling. So that's going to depend on whether those are going to be useful or not. So rail covers, probably best used for small areas. This was a study we had where we were looking at different weights and types for the fall and winter. And so the amount of protection you get from rail covers is going to vary. If you have a cloudy preceding day, you're not going to have a lot of heat build up under the rail cover. Sunny day, you will. Depends on when you pull the rail cover on. Typically, we'll pull them on maybe in the middle of the afternoon on a sunny day to try to avoid advancing the crops too much, but still get some heat build up under there. If you have wind, that can kind of blow the heat out from underneath the row cover. And then the fiber arrangement. So some row covers are pretty limp, I guess would be the way I describe them. And so they tend to lay down really flat against the crop. And when you don't have much airspace in there, you don't get as much protection from them. There are some that are a little bit stiffer, and they seem to do a little better job of getting you another degree or two of protection from cold events. So it's going to vary. So the stiffer fabrics tend to work better. Typically you'll want them to be at least 30 grams per meter squared, or heavier will do the best. You can use a single layer of fabric. And so on windy nights, you might only get, up to a degree of Celsius of frost protection. On still nights, you're going to get more though, because you don't have that wind blowing the heat out from under the cover. One thing you can do is put on a double layer. If you have another layer around, even if it has a few holes in it, you can use it as the lower layer and then put a second layer over top, and that actually helps out pretty well. But you do want to pull that off so you don't advance the crop too much, especially if you still have cold temperatures coming up. And then also so pollinators can get in. And so when it comes back to the double layers though, I mean, we did have one event that was a little bit breezy, where we were down to 21 degrees and we still were able to protect our blossoms. And it felt like, the top layer was maybe breaking the wind some, and then the lower layer was able to do some insulating. Was my theory on how it worked, because I did actually crawl under there to check the temperatures and felt pretty cozy. So anyway, if you have holes and you're in a pinch, you can staple them shut. That does work. I don't know if you are worried though about getting staples in your crop. And then one of the questions is, are there disease concerns with using a row cover that was used in a previous year? And maybe, but from what I understand from our pathologists here, you don't get a tremendous amount of inoculum that is viable on those row covers if they've been stored dry for a year, and especially if you've made some attempt to clean them off pretty well. One thing you can do is use them in combination with overhead irrigation. And I'll show you a slide on how that worked out for us in the past. You may have noticed behind Erica in her background, she had a picture of overhead irrigation, frost protection sprinklers being used over top of a row cover. So why does sprinkler irrigation work? That works because heat's giving off when the water freezes. And so it's the opposite effect of what's happening when it's evaporating. But the difference is it takes 7 times as much freezing as is evaporating in order to frost protect the crops. And what you're trying to do is keep a liquid water layer on the blossoms. And if you can do that, then you have to be at 32 degrees as long as that liquid layer is there. Where you get into problems is when the water freezes solid and you don't have a liquid layer, then the temperature of that ice can drop. And you also, will have additional evaporation taking place as some water is being applied, but it's just not to keep it in a liquid state on the surface of the ice. So it's really important to have enough water. And let's see, so one question growers have asked me is if they do something that helps to heat up the irrigation pond, like maybe cut down trees that are around it so some sunlight gets to there, will that help with frost protection? And it might, but it's going to be a very minimal effect. So in terms of BTUs, if a pound of water, which is, definition of a BTU is 1 pound of water dropping 1 degree Fahrenheit equals a BTU. And so we're switching to Fahrenheit here. But basically, you get that 1 BTU when the temperature of that pound of water changes by 1 degree. And so what that means is, for example, if your pond is at 55 degrees Fahrenheit or 12.8 degrees centigrade, and the water drops to the freezing temperature, you would get 23 BTUs released from that. So, maybe you can warm it up a few degrees, but it's not going to amount to much. However, when that same pound of water freezes, it releases 144 BTUs. So that's what's really having the effect of keeping your blossoms from freezing. So what happens if it's windy? You don't really want to be applying it when, you're getting some stiff breezes out of there. You're probably okay up to about, 8 kilometers per hour or less. If you get to double that amount, you're going to, of wind, you're going to have spotty protection. And then if it gets above that, you're likely to have more damage than anything else from the evaporation of that water freezing. And so you're going to be cooling your blossoms instead of keeping them protected. So our general rules of thumb when to start out is if you turn it on when you're slightly above freezing, that gets you some time to make sure that water's getting on there and it's not freezing and evaporating and cooling things. It basically gives you a little bit of a cushion in there to get your system going and start protecting those blossoms. So typically we'll say, turn it on at 2 degrees Celsius. And then, or 2 degrees above the critical temperature. And then that means, 1 degree Celsius if you have open blossoms, if you think your measurements are right and if they're reflecting what's actually happening in the field. If it's breezy or the humidity is really low, you can use that wet bulb temperature. There are also different tables out there that have different combinations of temperature and relative humidity that tell you what temperature to turn the irrigation on at. And so here's an example of what one of those tables would look like and the temperatures you would want to start your irrigation at. So, so if you want to, stay at 34 degrees, give yourself a little bit of cushion there, and your dew point is below freezing, you will be needing to start your irrigation at successively higher temperatures to account for the cooling that's going to be happening once you turn that irrigation on and you have evaporation taking place. So sprinkler rates, about a ½ centimeter per hour will get you through most radiational frosts. I do recommend setting up the irrigation, setting out some buckets and checking to see what you have actually falling out there. And this will also help with checking your pattern to see if it's even. This table we're not going to go over much here, except I just want you to know that a table like this exists. Depending on your relative humidity, which is generally going to be somewhere in this 50 to 75% range overnight, even when you have dry air. Depending on what the wind speed is and what the temperature and relative humidity is, you will need different amounts of irrigation. And so you just want to be sure that you're applying enough to be applying more than what you need to protect in your typical events, just to get you through some bad ones. Okay, so you want a fast rotation speed on your sprinklers, so less than a minute per rotation. Metal will not wear like plastic will. You can use just a single nozzle on your sprinkler head for that'll keep you from waterlogging the field too much. And you want a low trajectory angle so that you don't have so much of a wind effect if that does occur. And then this is one of the questions, square versus staggered. Intuitively, you probably would put the sprinklers out in a staggered pattern, but I want to show you what happens if you don't. So you do get more uniform application. Your sprinklers should be spaced apart 50 to 60% of the wetted diameter. So you want the water that is coming down to be hitting your next sprinkler in a line. And so if you look at what happens when you have a square pattern, what you can see here is these numbers are showing how many sprinkler heads, water from how many sprinkler heads are hitting a certain area. And so if you look at what's going on, a lot of the field will be covered by 4 different sprinkler heads, that in the area that is in between all 4 of those. But there will be some areas that will only be covered by 2. And if you stagger your sprinkler pattern, basically almost your entire field is covered by 3 sprinkler heads, and it's a much more even pattern. I just want to show you something that's going on currently, and the point of this is that sometimes you are better off doing nothing whenever you have a frost event. So this is our current event, what is forecast to happen for tonight, which isn't great. So so if you look at the middle set of graphs, what you are seeing there is the wind speed. So we have wind gusts that are happening now. This is in miles per hour. Up through about 8 o'clock, but we do have a steady breeze all night, and it's above the range where we'd really be feeling good about sprinkler irrigation. And then if you look at the top graph, basically what you can see there is that our temperatures are of course dropping off overnight, but the green line is actually showing the dew point, which is extremely low tonight. And so when we were talking about, calculating the wet bulb temperature, what would be happening, for example, at 2 o'clock in the morning, we would be 5 degrees Fahrenheit lower at the wet bulb temperature. So we're going to subtract the 14 from the 29, which gives us 15. A third of that is 5 degrees. And so our wet bulb temperature is this 29 minus 5 degrees. So our wet bulb temperature is actually 24 degrees. And what that means is if we turn the irrigation on, say at 2 a.m., thinking that, the flower buds are still tight, we're okay, a few degrees lower than this, you would actually drop the temperature below the critical temperature for the flower buds by turning the irrigation on. So what we're recommending for tonight is not to really do anything, or maybe use a double layer of row cover over top of those plants if they do have flower buds emerging. So there's a lot of reasons, why we wouldn't want to turn irrigation on tonight. The wind's one, but you're also going to need a high irrigation rate to protect. And then, like I mentioned, with the wet bulb temperature, that's actually, you're actually going to drop the temperature of the plants by trying to irrigate them. So one other option, as we mentioned, was applying overhead irrigation over top of row covers. And I'm just going to show you some of the temperatures we had. This was one particularly horrendous year where we had 9 nights of frost protection needed over about a month. If you take a look at our temperatures underneath the row covers, what you see there is that they were higher than the temperatures were outside of the row covers. And what that row cover did was that it allowed us to delay the turn on time for our irrigation until the temperature under the row cover was actually close to the critical temperatures. And so what you see in the column under the time is the time we actually turned the irrigation on. And then in the last column, what our lows actually were outside of the row cover. And then you can check back to what the temperature was over in the left column. We never actually had any damage from irrigating this way in this particular year. So just want to cover a couple of my favorite gadgets briefly. Frost alarm is really helpful. You'll just need to, check for differences between the field and wherever you have your alarm taking its readings, because it'll need internet access or depending on where you are. In some places, if you don't have good internet access, you might need a landline. So you may need to have that alarm somewhere other than in the field. Another device I use is a pocket weather station. This particular one gives you a lot of variables. You can take it right out in the field, get what readings on what your wind speed, temperature, or also the relative humidity. And the dew point right there on the site, so you can check down at ground level, see what the situation is. They're more expensive models that will also give you additional readings like wet bulb temperature. And then this is still my favorite, which is this color-coded light that actually changes colors depending on what the temperature is out in the field. And so it gives you some comfort to be able to look out of the field from, somewhere indoors that's a little warmer, or, even in a vehicle, and see what's going on with your temperatures actually out in the field. And so my cutoff would be when it would change from solid green to white. Then I would know I've got to get the irrigation on right away. It also works because you can put the probe underneath the row cover and tell what's going on underneath the row cover by looking at the light. So anyway, so every event's different, and that's everything that I have for you. But if you have any questions, I would be happy to answer those now.
Okay, thanks so much, Kathy. Here's that picture Kathy mentioned. I guess she had one up with the row covers and the frost too, but all right, if there's any questions, feel free to put them in the chat or unmute yourself or raise your hand, and then we can go through them. I guess to get started, I have a question for you, Kathy. After a frost event, how quickly do you think growers can go out to check for damage to the blossoms? Like, do you wait until the afternoon?
Yeah, so typically they'll still look pretty darn good in the morning. And they need to get warmed up a little bit, and you need some time for that damage to really show up. So So yeah, typically you will want to wait. You might start to notice that something's looking a little off later in the morning, but by afternoon you'll start to develop more of a tan color to them, and they'll get progressively browner over time until they're eventually black. But yeah, you might think you were fine
Mhm.
if you go out and check as soon as you turned your irrigation off or even an hour later, and that might not be the case.
Okay, thanks,
Mm,
Kathy.
yeah.
Kathy, when we're turning off your irrigation, I'm not sure if maybe I missed that the wrong way, but when do you recommend turning off?
Yeah, no, good question. Let's see, this sounds like this must be Kevin. So, yeah. So yes, so the turning it off is kind of the reverse of turning it on. Is that you want to, you want to wait until, if you have a wet bulb temperature, you can wait until that's above your critical temperature. That is one way of doing it. But typically, we like to see there's some sunlight hitting those plants, or seeing more meltings occurring than what you're applying. Sometimes folks will, wonder about waiting until the temperature is until the ice is largely melted off, but that can result in some additional water being applied that maybe didn't need to. But you do want to make sure, air temperatures are above the critical temperature, wet bulb temperatures, above your critical temperature, especially, and then seeing some melting occurring.
Yeah, thanks, Kathy. Yeah, feel free to yeah, unmute yourself if there's any other questions. I guess I have one more, Kathy. This is probably a situational question, but a few years ago we got multiple frost events in a row, but it was pretty nice and sunny during the day. So for row covers, do you have any recommendations on what growers should do in between, like those, like, yeah, should
Well,
we take them off, leave them on, or?
yeah, that is always, always a big question. I can tell you, if it depends somewhat on the crop growth stage. So if you were actually in open blossoms at that point, and I know some of it's going to depend on the practicality, of course, right? If you have acres, which it surprises me, the acreage people sometimes will use row covers on. For me, I don't, an acre seems manageable with row covers, or a hectare even, to, 2 acres or a little over. But I have talked to folks who will have, 5 hectares of row covers, on out there. So some of it's going to depend on also your labor, as well. But in a if you can manage it, I would really like to see those row covers come off on a sunny day. Um, sometimes I'll wait a little bit till they dry a little bit, so you're not dragging really heavy wet row covers over. So maybe wait until later in the morning, get a little bit of a breeze out there. But at least get them off for a while so some pollinators can get in there. Although honestly, I'm kind of convinced that dragging the row covers across the field does some pollination, to be completely honest. But also just to get some airflow through there, so you're not keeping everything wet and developing, more disease issues. Because if you have the row covers on there and you're holding in a lot of moisture, you are increasing conditions where you might have, more problems with anthracnose, fruit anthracnose. Our new disease, our neopestaloceopsis, we've, talked about from time to time, does like warm, wet conditions as well. And so I'd really like to see those row covers come off for during the day, um, you know, until you feel like, you're going to want to pull them back on to get some heat build up under them for the next night.
Yeah. Okay. Yeah, that sounds good. Okay, if there's, yeah, any questions, feel free to speak up. I guess just while we have a few more minutes left. Kathy mentioned some tables and like with dew point and temperature and when to calculate, um, when to start irrigation. So I'm interested in what other people use, but as far as I can tell, like the main dew point access that we have is Environment Canada will give you the current dew point and weather underground. But if anybody else has other recommendations in there, feel free to put them in the chat. But those are kind of the two yeah, the two sources of weather data that I use. Yeah, and thanks for putting that, yeah, irrigation fact sheet in there as well. Okay. If there's no other questions, I just have a couple more comments before we leave. I think there's a few folks here from Nova Scotia, so just want to let everybody know that the summer tour for NASGA is in Nova Scotia this year, August 12th and 13th, and that information is on the website. So Victoria, maybe I'll pop it in the chat here so people can check that out. There you go. So hopefully we'll see some of you in Nova Scotia this year. Okay, we'll do one last call for questions. All right. Well, thanks so much, Kathy. Really appreciate you joining us today. Oh, hang on. Yeah, so maybe I'll just read it out loud for the recording, but what is the temperature difference from just watering overhead versus water with sprinklers and row covers? Hang on, Kathy, you're muted.
I sure am. So yeah. So anyway, so that depends on the night, but typically what we were seeing, and yeah, and that was a lot of information to cover really quickly. I am going to send the presentation to Erica, and thankfully it's also recorded. So anyway, if we need to review anything, but typically on the nights when I was doing that, it was a minimum of 2.5 degrees centigrade and a maximum of about 4.5 degrees centigrade. So it depended on the night. There were some nights when we had a little bit of a breeze going on. And when there was that breeze, then there was more of a difference. So yeah. Okay, so question. So I don't recommend a portable wind machine with a row cover. I don't think so. I've never actually done anything to check that out though, but I would expect that you would get the breeze coming down. They might be kind of counteracting each other a little bit because the row cover is working because you don't have much of a breeze happening underneath it to basically, flush out the air maybe that might be being held underneath that row cover. And that's where your heat is coming from at that point, is really from the ground level. So I think a portable wind machine, especially if the row cover has gotten damp, might actually cool things down. Okay, have I found using row covers on older plantings have more disease pressure than a first year producing year? That's really hard to say. And I suppose it's possible, but I can't say I've really seen that necessarily. I think a lot of it has to do with the system and the disease susceptibility of those plantings, but I can't say I've really seen that necessarily happen more. When we've had an older planting. I don't know, Erica, Kevin, Victoria, anybody want to weigh in? Do you have any experience or any thoughts?
Yeah, I haven't seen a difference in between like older plantings and new plantings, but I don't know if anybody else has any other experience with that.
I have not seen that,
Thanks, Kevin.
I wasn't going to add anything else.
Okay, thanks, Victoria. Okay, I think that was all the